Welcome to the second adding video. Remember, like I said in the last one, which I hope you already watched, I talked about how when we add numbers together, we have math words for them, and we say add-in plus add-in equals sum. So I have given us two add-ins, and we need to find the sum. I also said that we are always going to think about math in a real world way, because we're not just doing math to do numbers, we're doing math to practice for all the things we're going to need numbers for in our lives. So let's imagine that Miss Sarah has 57 books in her classroom, and she gets 9 new books. I want to know how many books she has all together. Stop counting on your fingers. We're going to do it as a vertical math problem. All right, so let's first talk about aligning it vertically. Right now we have horizontal. We want vertical. So I'm going to draw my place value charts around it. Right here I have tens and ones. Over here I have a single digit number. What number is in the tens place? You're right. There is not a number in the tens place for the number 9. I only have one digit. But we could imagine that there is an invisible 0. We don't write 0 as our first digit in a number, but we can imagine that it's there. Let's align these now by a tens and a ones column. So here is my tens column, and here is my ones column. Let's start with 57. I have 5 tens and 7 ones. 5 tens and 7 ones. Over here I have 0 tens. Do I need to write it? No, it's invisible. And 9 ones. Okay, I need to draw my math symbol to show that we are doing addition. We're adding the numbers together. Our answer is getting bigger. There's going to be more books on the shelf now that Miss Sarah's putting 9 new ones. So we are going to build our number using base 10 blocks. I need 5 tens, 10, 20, 30, 40, 50. This represents the 50 of 57, and I need 7 ones. Is 7 even or odd, my friends? Think about it when I build it. 2, 3, 4, 5, 6, 7. Partner, 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 all by myself. That 1 right here is all by itself, so this is an odd number. Let's build 9. Think about it in your head. Do we count to 9 when we skip count by 2s? 2, 4, 6, 8, 10. What does that mean about that number if we don't say it when we skip count by 2s? Even or odd? 1, 2, 3, 4, 5, 6, 7, 8, 9, all by myself. So we're adding 2 odd numbers together. Let's see what happens when we add 2 odd numbers together. Do you think our answer is going to be odd or even? Let's see. Okay, we're going to start in the ones place like we always do with addition and subtraction. 7 plus 9. Let's start by counting up all of our ones together. 1, 2, starting over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 7 plus 9 is 16. How many digits fit in each line in our place value? If our answer is 16 and I have 2 digits, what should I do? I hope you said you should make a trade, Miss Reagan. So let's make a trade. I'm going to trade 10 ones for 1 10. So I have 2, 3, 4, 5, 6, 7, 8, 9, and 10. Stop. We can put 10 together and trade 10 ones for 1 10. Now I'm not taking these away. All I'm doing is making a a trade. I'm going to slide them over here. See how I still have 10, 11, 12, 13, 14, 15, 16 here together. But my 10 can't stay over here because this is the ones column. So I have to move it over here. And I'm going to represent it by putting a 1 above. My 1 goes up and my 6 goes down here because this is 10s and 1s. I have 6 1s and 1 new 10. 1 plus 5 plus invisible 0 is 1, 2, 3, 4, 5, 6. Very good. My answer is 66. 66 what? 66 books. Miss Sarah has 66 books on her shelf right now. Okay, let's do one more together. And let's think of a little bit bigger numbers. Let me erase and get us cleared for a new problem. Okay, I got my board all cleaned off and I have one more problem for you in this video. So we have the problem 49 plus 73 equals some number. Addend plus addend equals our sum. We're going to imagine that Mr. Chase has a big mango tree outside of his house. And he picks his mangoes and he has 49 mangoes. Yum! Then Miss Teresa picks the mangoes off of her big mango tree and she has 73 mangoes. Whose tree do you think is bigger, Mr. Chase or Miss Teresa? I think Miss Teresa's tree might be bigger. Anyways, let's get to adding and see how many mangoes Mr. Chase and Miss Teresa have all together. All together is a clue word that you are going to be adding, meaning your number is getting bigger. Okay, first thing we need to do is change it from our horizontal to vertical, right? So let's talk about our 10s and 1s. Here we have 4 10s and 9 1s. T stands for 10s, O stands for 1s, 7 10s and 3 1s. I'm going to draw my big T chart, including my 10s and my 1s, so that I am ready to put them where they belong. I have 4 10s and 9 1s. I'm leaving some space at the top in case I need to make a trade later. Are you predicting that I might need to make a trade? See? And then I have 7 10s and 3 1s. 7 10s, 3 1s. I draw my bar to show those are my only numbers, and my math symbol, which is addition, meaning my number is getting bigger, putting the mangoes together. My second step is going to be to build using my base 10. To represent the number of mangoes that Mr. Chase has, I need 4 10s. 1 10, 2, 3, and 4. Here's 40. And to represent Miss Teresa's, oh wait, I'm still building Mr. Chase's. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are Mr. Chase's mangoes. Does he have an even or an odd number of mangoes? I hope he said odd because 9 is odd and this one is all by himself. Now let's build the representation for Miss Teresa's mangoes. So we have 73. I need 7 10s. Wow, 1, 2, 3, 4, 5, 6, and 7, okay? And over here, we need only 3 1s. Look at that, I already had 3 in my hand. 1, 2, and 3. Looking at our ones place, is Miss Teresa's mango amount even or odd? Odd, very good. There's 1 all by itself. Okay, where do we start when we start adding in a math problem? In the ones place. 9 plus 3. We have 9 here. 10, 11, 12. Oh no, Miss Reagan, I have 2 digits. What can I do? You can make a trade. You know that only 1 digit will fit in each place value. We're going to make a trade. My 2 is going down. and I'm trading 10 of my ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not taking them away, just trading. I'm going to move them down here because now I'm representing them using a 10. 10, 11, 12. And this guy can't stay over here. This is the one side. I got to move it over, and now it is a 10. My 1 goes up and my 2 goes down. Here's a hint. Most of the time, your 1 is going to be the one that goes up. And if you forget about it, your answer is going to be wrong. You have to be careful. Okay, we have 2. Let's start counting up all of our 10s now. We have a lot of 10s. What are we going to need? Let's look. Okay, we have 1 plus 4. So 1, 2, 3, 4, 5, plus 7 more. 6, 7, 8, 9, 10, 11, 12. 1 plus 4 plus 7 is equal to 12. Oh man, okay. So this was 1 10 and 0 1s. What place value am I going to need to add to my problem? The hundreds place. Over here, I'm going to add hundreds, which I will abbreviate, which H-U-N-D. Hundreds place, okay? So now I have 12 10s. I only have space for 1 digit. What can I do? Make a trade. You're right. I'm going to trade 10 of these for 100. So let's try it out. Here we have 1, 2, 3, 4, 5. Let's put those all together and see if they match up. We have 6, 7, 8, 9, and 10. Looky there, it's exactly the same. So I'm going to trade these for 100. We're just going to pretend you can't see them back there. So now I have 2 10s, and I have 1 100. These are my invisible zeros. I bring my 1 down, 1 plus invisible 0 plus invisible 0. I have 122. Let's count up the base 10 blocks and make sure we have the right answer. So this is 100, 110, 120, 121, 122. How many mangoes do they have all together? 122 mangoes. Thanks for watching.